The Panorama project is working to improve design efficiency in the embedded automotive and aerospace domains. In this video, we'll describe the challenges presented by increasingly heterogeneous software, hardware, and teams. We will then introduce the line of research and software development we are pursuing to meet those challenges. Based in open source, Panorama provides an environment for collaboration among diverse hardware and software technologies and teams, especially at the early stages of design. It supports efficient design decisions by defining evolving standards, tools, and best practices for the exchange of non-functional formal models. EE architecture design is moving from the complexity of distributed systems to ever more centralized systems. Here we trace the path to future vehicle systems. Let's start with today, where we are moving from a distributed modular structure to one where functional integration is taking place. In the next generation, we will broaden the structures to domain functions and eventually to domain overlapping structures. Finally, in a centralized EE architecture, a central CPU will be domain independent and more functions will reside in the cloud. Panorama will address these interim steps, laying the foundation for a centralized vehicle system. This example of a braking system demonstrates the complexity of end-to-end analysis of distributed functions in vehicle networks. The system consists of the interaction of 4 sets of brakes, 2 radar units, and a front-mounted camera through the SDF and controller unit. When an event is detected, for example, by one of the radar units, we need to ensure that the actuators, that is the braking systems, are engaging in time and in sync. The Panorama design process is illustrated here. Deployment assessment and optimization on the target hardware is supported by the Automotive model, released as the open source project Eclipse App4MC. This part of the process focuses on use cases, meta-model details, and abstraction levels, along with transformations between meta-models and views. Here, viewers, editors, and model exchange tools are also under development. In this part of the process, resulting performance data is analyzed with both static and dynamic approaches. The project will provide the appropriate tools for analysis, storage, and visualizations to support designers in the assessment of the performance data. The resulting assessment then feeds back into the cycle of refining and negotiating requirements, ultimately expressed in the system model. Trace analysis artifacts linked by the Eclipse Capper tools are incorporated throughout the process. This enables system-wide assessment of the impact of changes. Current systems design focuses on abstractions related to software architecture. The new EE architecture requires consideration of the broader system environment. It requires design at various levels, ranging from high-level architecture view down to detailed feature implementation. Panorama is ready to support the design of tomorrow's systems, supporting additional abstractions including customer function, functional net, and system architectures. Panorama addresses these issues through an open ecosystem of software for efficient collaborative design. The project ecosystem includes different design and analysis tools based on the open source ecosystem. This enables collaborative workflows amongst the heterogeneous systems and teams. This environment is available as a system that permits the incorporation of commercial and open source components and can be tested today. The results of the project are continuously released in the Eclipse App4MC project. In order to achieve a thorough analysis of the technologies required for a comprehensive design flow for systems engineering, Panorama has organized its research into 6 focused topics. In our video series, we will present these research areas individually. To stay up to date with the Panorama project, visit our website or contact us at info@panorama-research.org. Thank you for watching this video.